Hello student, welcome once again, and this time we have an integral problem over here. Now we are to determine if the integral converges or diverges. If the integral converges, then we should determine the value of the integral. So we have the integral, the limit 0 to negative infinity, exponent 1 over s divided by s squared, then dx. So now if you look at this integral over here, now we can see an infinite limit, which is the negative infinity we see over here. So we have to deal with the infinite limit over here. So also the function is also discontinuous if provided s being equal to 0, then it is discontinuous, and therefore we have to deal with that also. Now the trick we are going to use over here is that we are going to split the integral into two. So we are going to split the integral into two, because if you look at the limit over here, we have it from negative infinity then 0. So we can have, along the line, we can have negative 1 over here. So let's split the integral into two. Now there is a reason for that, so quickly let's do that. So we have solution, we have 0 negative infinity, e exponent 1 over x here divided by s squared dx. So in splitting the integral, we have it from negative 1, then we can have negative infinity here, then we can have 1 over x here over s squared dx, then plus from 0 negative 1, then we have 1 over x over s squared dx. All right, so we splitted the integral only because we are sure that both integral you see over here will converge. If we solve and we put in the limits and the integral converges, then it is right that we split the integral. So but if we solve and it diverges, then we could not have split the integral. So let's do that. So from here, what we are going to do next is that, since we have to find whether it converges and diverges, we have to apply limit. So we apply limit to both integrals. So we have 0 negative infinity 1 over x here, then s squared dx. This one will be equal to the limit. So let's say a variable t, as it approaches negative infinity here, we have negative 1, then we can say t to the power 1 over x over s squared dx, plus also the limit. Let's say s here is approaching we'll approach 0, then let's put 0 here, and let's put so we have negative 1, then 1 over x here over x squared, then dx. So this is what we have. Now what we are going to do next is that we have exponent 1 over x s squared on both sides. So generally we have to solve this integral. Now generally, if you have an integral, let's say e to the power 1 over x over s squared dx. So over here we are going to use substitution, so integration by substitution. So over here we let u be equal to 1 over x, then the u with respect to x will basically be, because this is just negative 1, so differentiating this will be negative, we drop the negative 1, then minus 1, so we have negative s squared. So therefore we have the u being equal to the x here, we have the x here being equal to negative 1 over s squared. All right, so therefore what will be our dx? So our dx here, the x here will just be negative s squared du. All right, so let's put that into the general one here, this general one. So so having this, then therefore we are still looking at this. So we have the integral as with respect to u s squared then we have the so we have the x, so the s is just negative s squared here, then the u, right? So with s squared will cancel s squared. So when s squared cancel s squared out, we have exponent u, then we have the u, which is just there's negative here, so we have negative exponent u plus c, which is just negative. Remember we said let u be 1 over x, so we have that for the general one. So our general integral is just 0 negative infinity, and we have e to the power 1 over x over s squared dx will be equal to the limit. So we have here the limit as t here is approaching negative infinity, and we have that one to be negative 1, then we have our t here e to the power 1 over x over s squared dx, right? Then plus the limit as t is approaching 0, sorry, we use x, so we have 0 negative 1, then e exponent 1 over 2 divided by s squared dx. So this is what we have. So let's integrate that. So integrating that, we have t going to negative infinity. The integral of this, we said generally will give us that, will give us this. So integrating this, we have negative e 1 over x here plus, so we are taking away there because this time we have limit over here, so the limit negative 1 to t, then plus the limit as s here is approaching that, we have negative 1 over x here, but this time it is 0 and then negative 1. So that's it. So what we are going to do next is that we are going to put the limit into it. So putting the limit into that, we have the limit as t is approaching negative infinity here, then we can have negative that over t, then minus e, so it will be minus minus, which will be plus, right? Then we have 1 over negative 1 for this, then we have the limit as s is also approaching that, negative, that is 1 over 0, then that one also plus e to the power 1 over negative 1 here. So this is what we have. Now from here we have the limit as t is approaching negative infinity, then this here will just give us okay, so it's negative 1, so this first, then we have over t, so that one will give us negative 1 here, then plus e to the power 1 over t, so 1 over t is just 1 over infinity, 1 over infinity is just 0, then plus the limit as s is also approaching 0, then we have so this one, so we have 0, 1 over 0, so over here the negative to the power 1 over 0 will just give us 0, then we have plus e to the power negative 1. So in whole we have the limit as, so if you look at this limit over here, now we had the limit, we said the limit as t is approaching that infinity. So okay, so let's look at it this way. The first limit we splitted, which was from negative 1 then all the way to t, then we have e exponent 1 over x over s squared dx here, so that is what gave us negative e, negative 1, then plus 1, so e to the e exponent 0 is just, so we have negative exponent negative 1 plus 1, so that is for this one. Then for the second part, which the second is limit, which was from 0 to negative 1, e 1 over x here over s squared dx, give us we only have negative exponent -1 as that. So therefore we can write the general one. So generally we had that the integral from 0 all the way to negative infinity exponent 1 over x over s squared dx, right? S squared dx is equal to -1 here. We had the negative infinity, then 1 over x here over x squared dx plus 0. Then we have -1 e exponent 1 over that s squared dx. So over here we had our answer to be e -1 plus 1 as that, plus over here we had e exponent that. Now if you look at the two integral, now as I said from the beginning, we splitted these two integral because we are sure that both integral will converge, right? So if you had this, you realize that you're getting some decimal values which converges. Exponent -1 2 will also converge. So the summation of these two integral, when we sum them up, we are having our final answer to be just 1, because at the end of the day we have this value here. This value here is somewhere around 6.32121, and this value here is somewhere around 0.36788, which it shows that it converges. So therefore we can conclude that the integral, so we are concluding that the integral converges, and its value is 1. Alright, so thank you very much for joining me in this section, and I will see you in another section.